My name is Marcel Böhme. I'm a senior lecturer at Monash University, and when I was invited, I asked what I should present about, and presented some topics. And Sergey said, maybe you talk about fuzzing challenges and reflections, the topic that I proposed. So fuzzing is not a solved problem. There are open challenges, and what we did is back in 2019, last year, we organized a Shonan meeting in Japan where we wanted to talk about open challenges and opportunities. And this was co-organized with Abik from the National University of Singapore and Christian Kodar from Imperial College London. And we invited keynote speakers like Patrice from Microsoft and Kostya from Google. And so we invited people from different communities, search-based software testing community, symbolic execution community, from the fuzzing community, but also from industry and from research. We had Peter Goodman representing Trail of Bits company. We had Andrea Seller representing CISPA in Germany. We had Kostya representing Google, fuzzing efforts at Google, Xiangyu Chang representing fuzzing efforts at Purdue, Caroline Lemieux representing fuzzing efforts at Berkeley, and a lot of other people, rising stars and thought leaders all in fuzzing, both from industry and research. And so we discussed these open challenges and live tweeted about this discussion. And so this discussion then extended into the Twitter universe and kind of bounced back. So we told the Twitter community what we were discussing, and we got some feedback from this as well, and integrated this feedback back into our discussions. So then we came up with an explicit set of challenges, and we distributed this set of challenges to the community again. We wrote a draft and asked about their opinion on this in a survey. So what I'm saying is that the challenges and reflections that I'm discussing now doesn't come from myself or from Apik or Christian, but these are challenges that come from the community. So we start with reflections. So what I put here is the internet and the world's digital economy runs on a shared critical open source infrastructure that no one is accountable for. So you might not know that a lot of things on which the internet is running are open source libraries. And so there's OpenSSL, there are a lot of parser libraries. The reason is no one really wants to be accountable for this, right? And there are a lot of people. So if you're a company and you want to develop, for instance, a protocol implementation for secure communication between any two parties in the internet, you don't want to be responsible for security issues in that. And furthermore, if you make this available open source, then other people can go and look at the implementation and then scrutinize the security of these systems. So a lot of these really critical systems are open source. But most open source licenses, essentially, if you're a developer of open source, you also don't want to be accountable for the security implications for you only want to contribute, right? So there are a lot of open source tools available that are upon which the internet is running, and ensuring the security of these libraries and also in organizations and companies is really important. And so fuzzing has had a substantial impact. For instance, this is a picture of the Davos Cyberpunk Challenge, which was organized a few years back and kind of initiated a lot of fuzzing research as well. So what enabled this recent surge of interest? Firstly, there's a tremendous need for automatic vulnerability discovery. So these are just some random facts that I gathered on the internet, but the first point says the security market is forecast to reach $170 billion in 2022. So there's a lot of a lot of attacks happening, and you want to when you make your when you have a digital economy, you want to make this as secure as possible. And also with everyone going digital now, we need security, not only of open source software, of any kind of software. So here's another evidence that there's a need for automatic vulnerability discovery. Google pays, and only in 2019, paid $6.5 million US. And that's like almost double the price they paid in bug bounties since 2018. Facebook, 2.2 million, was last 2 years, 1 million. So there's a tremendous need. Secondly, we now have the incentive and the required mindset. So we have programs that incentivize independent security researchers to scrutinize software security and other systems. Also, we now have the tools for automatic vulnerability discovery. For instance, we have AFL and CLE, and most of these things are open source and freely available, and they're easy to use. At least in my opinion, and they're also very successful in finding bugs. And there's also a meaningful engagement happening between industry and academia, which has led to rapid advances in fuzzing. So for instance, this effort, FuzzCon, is a community building effort. Right? Shonan was a community building effort. People are coming together in meetups and discussing fuzzing, right, across industry and academia, between industry and industry. And people are starting to adopt our academic research as well. For instance, a tool that was developed in my research team was recently integrated in libfuzzer and then later enabled in ClusterFuzz, which is fuzzing Chrome and a lot of open source software projects. And then there's efforts like AFL++. Mark, you should talk to Mark van Hauser, for instance, to help them extend this tool, AFL++. And they are reaching out to researchers and integrating this research into their tool to make AFL even better. So people are talking about this. This exchange is really meaningful and helpful. So here is Brandon Falk, also known as Gamoso Labs, who's doing paper reviews. He's someone from industry. He doesn't have a PhD, at least not to my knowledge, but he reviews papers, academic papers, and sees whether there are ideas that he can use or not. Of course, there are a lot of rams, but like with any feedback, there are some nuggets that provide a lot of insight, and some nuggets that don't provide a lot of insight. But you should focus on those that provide insight. And so this gives feedback from industry to academia as well, right? So now challenges. So when I talk about challenges, I just put a disclaimer here. I only put forward questions. I'm not actually giving the answers. Maybe there's some suggestions. But yes, in the Shonan meeting, we mostly found what the key problems are in fuzzing research and industry. So the first and most important challenge is automating the problem of vulnerability discovery. So the first challenge was, how can we fuzz more types of software systems? So we have a talk on fuzzing automated software, automotive software later, and we also have a talk on fuzzing the Solidity compiler. We know how to do command line tools, we know how to do individual units, but we don't know how to do cyber physical systems or polyglot software, which is written in a lot of languages, or how to fuzz GUI-based software, right? So this is a challenge, and there's a lot more going to happen in this challenge as well. Then next challenge is, how can the fuzzer identify more types of vulnerabilities? So we know how to do memory corruption bugs, but we don't know how to do side channels, or we don't know how to do domain-specific vulnerabilities like sandbox escapes or kernel exploits. Or these are examples. There's some research going on in this field as well. Or language-specific vulnerabilities, like in Java, some deserialization vulnerabilities. So how to detect those? The third challenge is, how can we find deep bugs. And as you will see in FuzzCon, there are going to be a lot of talks on this particular topic. So I always compare fuzzing research like 2 or 3 years ago. It's a little bit like a gold rush. A lot of gold was found. A lot of CVEs were found back then with fuzzing because there were many unfuzzed systems. But when you look at a fuzz system now, most of the bugs are found. So how do we reach these deep bugs? So there's research on dictionaries, mining grammars, mining protocols. There are fuzzer roadblocks. And the fourth challenge is understanding the empirical nature of undiscovered vulnerabilities. So this is a call graph or a control flow graph where elements, basic blocks exercised by the fuzzers are light up. So what are fuzzer roadblocks? Where does a fuzzer get stuck? Which kind of vulnerabilities are difficult to discover? So this kind of empirical research is needed in order to understand how to automate vulnerability discovery. Then the next category is the human component in fuzzing. So how can the fuzzer leverage knowledge from the auditor? So we had Ned Williamson from Google's Project Zero tell us how he fuzzes software. So as researchers, we think fuzzing works as you take the fuzzer, throw it at a program, and just collect the bugs. But that's not how it works. What happens in industry is you write a really good fuzzer harness, and this can take a long time. How do you connect the fuzzer to the subject? And then Ned would identify fuzzer roadblocks. Where does the fuzzer get stuck? And then patch out these roadblocks, and so help the fuzzer kind of reach the vulnerability as fast as he can in this gradual process. And then once he found the vulnerability, he would patch back these roadblocks and then repair the reproducer. So how can we support this interactive way of bug finding? So usability, that's another problem. And there was a talk just now by Matthew, but the next talk is also going to be on usability. How can we improve the usability of fuzzing tools? So we should fuzz everything, right? We should integrate fuzzing into continuous integration. We should integrate fuzzing into IDEs, or we should even extend fuzzing and put them into our development processes. So fuzz-driven development is a term that KCC came up with. So here's a small anecdote from the Shona meeting. Kostya was giving this keynote, and he said that they were integrating this new library into OSS Fuzz, and somehow OSS Fuzz stopped finding bugs in this new library, and they didn't know why. So then later they get an email, and they found that now they integrated libfuzzer in their own continuous integration, the CI pipeline, and it prevented 3 vulnerabilities from even reaching production, from even reaching into OSS Fuzz. So this easy integration into the continuous integration pipeline is prevented bugs from entering production. The second most important challenge is fuzzing theory. So we must put fuzzing on scientific foundations. We don't want to just turn some screws here and there and see what works. We want to have a deep understanding of how fuzzing works and build intuition for fuzzing, and then make leaps rather than small steps. And the most important challenge that is maybe not so important for someone who's using fuzzing, but for someone who is building fuzzers, is the evaluation and benchmarking. And there's been a lot of discussion around this problem of evaluation and benchmarking, both at Shonan, but also on Twitter and other in the entire community. So the objective of benchmarking is to establish which fuzzer finds a larger number of important bugs within a reasonable time in software that we care about. The problem is that we don't have benchmarks with large number of important bugs. We don't know what a reasonable time is and what is software that we care about. So software that we care about. What makes a fair fuzzer benchmark? How can we, for instance, how can we evaluate specialized fuzzers? There are fuzzers that work only in specific program domain, or there are fuzzers that only work for specific use cases. You can't just send them and compare them across all fuzzers because they're specialized. So the suggestion in the Shona meeting was you have special benchmark categories for specialized fuzzers, as in this competition called TestCom. The other challenge under fair fuzzer benchmarking is how do we prevent overfitting to a specific benchmark, right? Once there is a benchmark, people would start overfitting their fuzzers to that benchmark. How can we prevent this? So there were 3 suggestions in the meeting. One is, and they're all inspired by work by other benchmark tools. You could submit and peer review the benchmarks as well in addition to the fuzzers. That's what TestComp does. So you would have a benchmark and submit your fuzzer, and your fuzzer will be evaluated on your benchmark and other benchmarks. And that makes it more fair. Then you could regularly evaluate new and unseen benchmarks. Essentially, you would hide benchmarks for the fuzzer building, but make these benchmarks available later. That's what the approach that Rodeo Day is taking. Or you have something like continuous evaluation on a large and growing set of diverse real-world benchmarks, and that's the approach that Fuzzbench is taking. So the next question is, and this was the 3rd most important challenge, is a good measure of fuzzer performance, right? We said finding a larger number of important bugs, but we don't have a large number of important bugs, and what even is an important bug. So there is, in order to construct a large number of bugs, we can synthesize these bugs. And but are they realistic? You can synthesize a large number of bugs for your special use case even. So there are 2 schools of thoughts. One is time to retire these synthetic benchmarks that are actively harmful, and there's some saying that you should really, in order to understand how fuzzers work, you should start generating small programs and see how that works. And also, there's research in making synthetic bugs more realistic. So, how representative are they even then? Another challenge is, are real bugs representative? Are real bugs representative? So is your set of real bugs large enough to be representative of large and important bugs? If you have a small number of bugs and your fuzzer performs really well, does it perform well for more bugs? And are discovered bugs representative for undiscovered bugs, right? The only ones that we can evaluate with is are discovered bugs. But what we're really interested in are the capability of finding undiscovered bugs. Another challenge is, so we've been using code coverage to evaluate our fuzzers. That's, for instance, in Fuzzbench, but that's also in many papers we use code coverage and compare code coverage because it's just very cheap to measure, and because we sometimes don't have real bugs available. What is the correlation between code coverage and fuzzer effectiveness? Also, what is a fair choice of time budget? So you would say, particularly as a PhD student or a young researcher or a company with not a lot of resources, maybe we try our fuzzer for 1 hour because we don't have the computational resources to do more. Then 1 hour or 6 hours or 24 hours or maybe 3 months, because there are some companies who run their fuzzers for months on end. Maybe your fuzzer performs really well only at the beginning and finds these shallow bugs, but maybe and there's this other fuzzer which performs not well at all at the beginning, but then finds all these deep bugs later. So what is a fair choice of time budget? Or and The third challenge under evaluation and benchmarking is, how do we evaluate techniques and not implementations? So we've been extending techniques, right? In research, we are interested in trying new techniques, innovating new techniques, and like symbolic execution. How do you truncate the state space, or how do you maximize coverage, or but then we have to implement these techniques, and then they end up in tools like AFL or in CLI, and then we end up comparing these implementations. What kind of conclusions can we draw for the techniques? So here is the utility of benchmarking. Fuzzbench was released after our Shonan meeting, and this release led to tremendous advances just over the last few months, essentially, in the main tools, LibFuzzers, AFL, and HongFuzz, and they all created Fuzzbench. And there are other benchmarking platforms. Just recently released Magma. There's Rodeo Day, and there's a testing competition. So benchmarking is really important to kind of, it has enabled a lot of advance. So there's a lot of value in this. So what are the opportunities ahead? So how do we address this problem of everything being vulnerable, or we all being stakeholders of open source software? How do we address this at scale? So we should continue to open source, have open science, and have this open discourse, because it has fostered this meaningful engagement both between industry and academia. And it has also fostered tremendous recent advances, both in the symbolic execution community as well as in graybox fuzzing. And open source, speaking of open sourcing, Microsoft just is going to announce on September 18 that they also have an open source fuzzing platform. So really looking forward to that. You should also educate developers and students on fuzzing. So this means we should develop educational content, such as tutorials and textbooks. And there's a lot happening right now. And this ethical hackers are coming up with their own tutorials, how to use LibFuzzer, AFL, and so on. And companies are coming up with these tutorials. But also we as academics should start integrating software security courses into our university curriculum. So here's an online course from Arizona State University, Pwn.college, which talks about sandbox escapes and a lot of concepts around ethical hacking. There should be more efforts like that. I'm also a co-author of a book called The Fuzzing Book, which you should go and check out, which is giving you, like, in a tutorial way, a tutorial style. You can actually try writing your own fuzzers, extend existing fuzzers that are written in Python. And the main author is, so there are a lot of authors, but the main author is Andreas. And as an organization, you should take matters into your own hands. You should adopt fuzzing, for instance, using your continuous integration. You should make your tools available as open source. You should establish competitive bug bounty programs. If you cannot, you can at least join bug bounty programs. And there are also cross-organizational security efforts, like the Open Source Security Foundation, which has just been founded. As an individual, you can join the fuzzing community. You can submit pull requests to CLI, AFL++, and so on. Make your tools available as open source. Organize support hackathons and support an open source project. For instance, you add one to OSS-Fuzz, or you fund one on HackerOne. Okay, so what I talked about today was some results from the show meeting, which then, where a lot of thought leaders and rising stars from both academia and industry talked about challenges. There, I talked about reflections. I talked about those challenges. I talked about challenges in evaluation and benchmarking. And I also talked about opportunities that we have. So now I welcome questions.
All right. In the Slack channels, there were no questions so far. Can you read the questions yourself, or should I moderate them?
Maybe you just read them.
Yeah, there's a question. Are there any references to the Microsoft open source fuzzing framework?
To the open source fuzzing framework, OSS fuzz?
Microsoft.
Oh no, this is going to be, so this is only something which I picked up from Twitter. This is, there's a conference called CPPCon, and so I don't know any details.
And another question, do you think, how do you think these benchmark standards will be communicated back to the community?
Can you repeat that question?
How do you think these benchmark standards will be communicated back to the community? Well,
there's a lot of discussion. So there's several channels. One is the quickest channel is Twitter, but there's Discord. But there is, and for us, academia, there are papers. So this takes a while, but this is also a sound way of evaluating this. Answering these questions in a more fundamental way. What makes a good benchmark, and what are good measures of fuzzer performance? For instance, to answer this question, whether coverage is a good indicator of test suite fuzzer effectiveness, we would have to conduct experiments, and that would then be evaluated and published in papers.
Okay, I think that's enough questions for now. You can ask all the questions in the Slack too. Marcel is in there. He can answer there too. And we will go on with the next speaker. Thank you, Marcel.